Okay, good evening, one and all gather here for day 3. AICTE ATAL sponsors 6-day online faculty development program on IoT data analysis with practical and exploratory approach. Let us begin with this event with a silent play. Now I invite Mr. A. Selvakumar sir, Assistant Professor, Department of Computer Application, to deliver a welcome address and introduce chief guest. Selvakumar sir.
Yes, sir. Good evening, one and all gathered here. With immense delight, I welcome you all to the most innovative 6 days online ATAL FDP on IoT data analysis with practical and exploratory approach. It's my honor and privilege to welcome and introduce our esteemed resource person, Dr. R. Uma, Head and Associate Professor, Nadar Saraswati College of Arts and Science, Theni. Next, I welcome our Director, Dr. R. Venkatesh Kumar sir, faculties and scholars from various institutions. This gathering is intended to help us learn more about the subject of machine learning methods and techniques for IoT. Let me share our chief guest knowledge gaining process with you. Ma'am's qualification is MCA, MPhil, SET, PhD. Ma'am has 21 years of teaching experience. In 1998, she completed her BSc Computer Science degree at Madurai Kamaraj University, Madurai. In 2002, she completed her MCA degree program at Madurai Kamaraj University, Madurai. In 2007, she did her MPhil Computer Science at Madurai Kamaraj University, Madurai. In 2017, she pursuing PhD Computer Science at Alagappa University, Karaikudi. In 2015, ma'am cleared the SET exam in Mother Teresa Women's University. Dr. Uma Madam was started her career at Nadar Saraswati College and worked as Assistant Professor of Computer Application Department during the period 2007 to 2010. Now she is working as Head and Associate Professor of MCA Department at Nadar Saraswati College, Theni. Ma'am has published 26 research papers in international journals and presented various papers in national and international conferences. She has published 5 books. She has acted as resource person for various symposiums, webinars, and conferences. She has acted as a member of BOS, technical and subject expert for various colleges, possesses strong skills in positive motivation, effective team collaboration, and critical thinking. Ma'am, we are eagerly waiting to know about machine learning methods and techniques for IoT. I once again welcome all of you. Thank you, one and all.
Thank you, sir. Now I welcome Dr. R. Uma ma'am to make the sessions more valuable on this topic, machine learning methods and techniques for IoT. Madam, session is over to you.
Yes, thank you very much, sir. First of all, I would like to welcome everyone for this 6 days online ATAL AICTE ATAL faculty development program. And a special thanks to Dr. Venkatesh Kumar sir and Madam Agnes madam and Dr. Vinod Kumar sir for providing me such a wonderful opportunity to take part in this 6 days online faculty development program. Thank you very much, sir.
Ma'am, you can share your screen.
Yes, sir. Screen is visible, sir?
Yes, ma'am, it's visible, ma'am.
Yes, the given topic to me is machine learning techniques and methods in Internet of Things. So here we are going to see, or we are going to divide this section into 3 parts: machine learning, Internet of Things, and the machine learning methods in Internet of Things, which we are going to integrate the Internet of Things with the machine learning techniques and methods. So before starting, we should know what is machine learning. So as we all know that the machine learning is a currently very emerging technique which we are following, and it is a part of the artificial intelligence, and that uses the algorithms to enable the computer to learn from data, identify pattern, and it is going to take the decision without being explicitly programmed. What is the meaning for this? Here, we are going to make the machine to learn by itself. How it is possible? When we are in the childhood period and until our growth, we may have many more experiences and we may face many more situations. So, from the situations, we have gathered many trained data. That trained data will be helpful for us in future to take any decision in any critical situations. So likewise, we are going to learn to the machine to take the decision in any kind of the situation. So that concept is applying in the machine learning. So in the machine learning, we are going to give the data. That data is called as a training set. So training set of the data will be given or will be stored in the machine, and the real-time data will be, when it is given as an input, then the in real-time data will be compared with the trained data. If there is any matching, then automatically solution will be given. If not, if does not matching, if it matches for the 50% or 75%, then the resemblance will be considered and it will give the output. So output of the decision. So likewise, we are going to make the machine to learn to take the decisions of any kind of the problem. This is called the machine learning. So these are all the key features of the machine learning: automatically discovering of the pattern, doing the prediction, and it is going to create a new actionable informations, and it can analyze a large volume of the data. This is the main key feature of the machine learning, why we are using in our field. So since the data or real-time data which we are obtaining are in a very huge volume, so that huge volume of the data can be handled through the machine learning methods, so that this machine learning is used in many places for analyzing or prediction. So this machine learning consists of the three important techniques: supervised learning, unsupervised learning, and reinforcement learning. So as we know all, supervised learning means in literally we are supervised learning means under supervision processing will be carried out. So here the training data set, that supervision can be considered here will be in the form of the training data. The training data will be given, and finally the testing data will be given as an input. Training data will evaluate the testing data to come into a prediction. So here the two important techniques, classification and regression, are used in the supervised learning. And these data are called as the labeled data, because here the training data are given here. So through the regression and the classification. So regression means when we have the continuous value of the data, then regression algorithms or regression techniques can be used. Suppose if you are going to predict the class label, depends upon the class label. If we are going to predict or classify the items, then the classification methods and techniques can be used in the supervised learning. And this is an example of the supervised learning. So here the labeled data are given, and in the training label, we are going to identify that this is called carrot. This color will be in like orange, and this is a tomato. It will be round in shape, and the color will be red in color. And this is called the bell pepper, and it will be in green in color, and the shape will be more or less like this. So this training set will be given, and in the test data, it will be grouped, or it will be classified given input depends upon the prediction. So this is called the supervised learning. And unsupervised learning, it is a machine where algorithms are the unlabeled data, and it is going to find the hidden patterns and structure. And here it is going to how it is going to find out the hidden pattern or structure means it can be done during the using the clustering or dimensional detection and anomaly detection. So the resemblance of the data will be collected together in clustering, or we are going to identify, or we are going to reduce the dimension of the data. And if there is any irrelevant data is available, like outlier, it can also be detected through the unsupervised learning methods. So here all the data are given as a unlabeled data will be given. So that unlabeled data, based on their classification, based on their patterns and structures, it will be automatically grouped together. Here, this is an unsupervised learning example. So here the raw data are given. So more or less the shape or the pattern of the data will be evaluated and it will be divided into a groups. So here is an unsupervised learning. And the third one is a reinforcement learning. So reinforcement learning is a learning in which it is going to act as a like environment feedback will be obtained. So based on the environmental feedback, either it may be the positive feedback or a negative feedback, iteratively it will be given the feedback to the input to obtain the output is called the reinforcement learning. So here it acts as an agent. That agent will act you or agent will make you to take the decision or to come into the output. So that is called the reinforcement learning. And this is a reinforcement learning. Here the environment is considered as a agent. So suppose, for example, if you are going to attain any particular place to the destination, if there is a one route, if you are going to travel from A to B, if there is a direct route, while we are traveling in the direct route, if there is some hurdles due to the road blocking, if there is any obstacle, then we have to take an alternative route to reach the destination B. So that obstacle and the obstacle will give the data that in this way you cannot use the road. So automatically we have to find out the alternative solution to attain the destination B. That agent will help you how to attain the or how to make the decision to come into the destination. This is the reinforcement learning. And this is the overall machine learning structure. Here we are using the supervised learning, unsupervised, reinforcement learning. These are all the applications of the unsupervised, supervised, and reinforcement, like compression, big data visualization, and recommender system, customer segmentation. These are all the unsupervised learning applications. And the supervised learning applications may be the image classification and the customer retention, fraud detection, estimating the life expectancy, and market forecasting. These are all the supervised learning. And the reinforcement learning means real-time decisions and robot navigation, skill acquisition. These are all the general format or a general technique which are all used in the machine learning with some examples. And here the machine learning techniques are both the supervised as well as unsupervised. In supervised learning, we are using the classification and the regression. In the classification, we can use these are all the algorithms, which are all the very famous algorithms, which are all highly useful, and they are all proved that they have much better result than compared with the other classifications algorithms like KNN, Navy Bayes, support vector machine. These are all used for the classification. And for the regression, linear regression and also the support vector regression can be used for the regression. These classification and regression will come under the supervised learning. And in the class clustering, the K-means algorithm, density-based spatial clustering of applications with the noise and neural networks. This is a feed-forward neural network. This is used for the unsupervised methods. So this is about the machine learning. So in the machine learning, which technique we are going to use, that can be supervised, unsupervised, or reinforcement learning. Next, we are going to focus on the Internet of Things. So what is Internet of Things? It is a network of physical objects where some applications of the machinery like a sensor can be embedded into them, and we are going to connect the machine to get the data from the other devices. So in which device we are connecting the sensor, from that device we are going to obtain the data. So why we are going to obtain the data and what is the purpose of this IoT means, there are 4 types of data can be obtained from the Internet of Things. And also these sensors are embedded with the real-time machineries, so we can get a huge volume of the real-time data from this sensor from various environments. So from where we can get the IoT data? It is a consumer data IoT, commercial IoT, industrial IoT, and infrastructure IoT. So these are all the types of the IoTs from where we can get n number of data. Of course, it is a structured as well as unstructured data. So a huge volume of the data can be obtained from all these four: consumer IoT, commercial IoT, industrial IoT, and infrastructure IoT. So what is a consumer IoT? So consumer IoT is like our day-to-day life, daily day-to-day life, how we are using within ourselves. That is a consumer. Ordinary human being are using many devices. So from that devices we can get the data. Like in the smart home itself, if you taken, then maybe the thermostat, a security camera, or voice activated assistant. Like from these devices we can get the data from every home. So that data will be, why we are going to get the data? So that data will be obtained for doing some processing and to deploy into a model. So this is a consumer IoT. Commercial IoT means this is a business or customer experiences. So in the business means it maybe in the healthcare. In the healthcare, if you have taken the healthcare domain, in that domain we can obtain the data of the patients to the doctors. So the doctor need not come to the hospital. By monitoring the patient's activity, temperature, everything in his domain place, and he can suggest the medicine, or he can suggest what step has to be taken for the patient's recovery. And for the smart building, the automated control in the lighting and temperature. Like these are all the commercial internet of things. The next one is the industry IoT. So industry IoT, we are going to apply the sensor in the machinery parts. So machineries, and then in the logistic item, and we are going to identify whether the product has reached into the destination place in a proper way, or if there is any traffic, or is there any time delay. If there is any time delay means, then we can very easily identify where the items are going, or where the truck is stuck in any places and all. It can be identified in the office itself. So this is the data which we can obtain from the industrial IoT. And the finally, infrastructure IoT. So the infrastructure IoT means, the best example are the traffic management and public safety benefits and all. So if there is any traffic, then what is the cause of the traffic is identified through the IoT devices. So from these four Internet of Things, consumer, commercial, industry, and infrastructure IoT, we can obtain n number of data. And this is a general architecture of the IoT. First, we are going to gather the data, and that data can be transmitted into any gateway, and we are going to do the process the information, and after processing the information, a smart application will be developed. So this is an IoT, where the Internet of Things data can be obtained, and how it is going to be converted into a smart application we have seen. Here, why we are integrating. So why we are integrating the machine learning into an IoT. In computer field, generally, if you are using a single technique, it has its own advantages and disadvantages. But if we integrate another one technique into the existing technique, definitely the result will be very, very smarter, and very adaptable, and very efficient. Likewise, if we combine machine learning with the IoT, it will be very, very powerful, because the Internet of Things will give you a huge volume of the data, and in the machine learning can able to classify or predict, or it can able to bring out a very fruitful pattern or fruitful model for the better result. This integration of the machine learning and IoT plays a very vital role in nowadays research. The real-time research models can be used by integrating the machine learning and also the Internet of Things. So here the large volume of the data is obtained from the IoT. So we can predict the failures, or we can optimize the consumption, we can improve the user experiences. This is very small, very little bit examples. This is a very little bit models, but the benefits are very much. So greater operational efficiency, and it definitely will do the cost reduction and the very better decision making, and it is used to ability the proactivity to changing the conditions. So from these objective only we are going to integrate the machine learning with the Internet of Things. So to understand the machine learning, to enhance the IoT project, we are going to we should know the basic concepts of the both the fields, and now we are going to do it. So here in the Internet of Things, many sensors are used. So from the sensor only we are going to get the data like temperature, humidity, and motion, everything, pressure, air quality sensor, everything for each and everything. For finding out the temperature, there is one sensor. Find out the humidity in the air, there is another one sensor is used, and from that sensor we are going to get the data. Of course, we are going to get the data in the structured and unstructured format, but it is vary in volume, velocity, and variety. So a huge volume of the data can be obtained from the variety of sensors where we are using. And here, how we are going to integrate, we can see in the step by step. First step, we are going to collect the data and we are going to prepare the data. So how to collect the data? It can be in the direct connections, or it can be the IoT gateway, or it can be in the API or cloud services. So that is both in the real-time data or already stored data can also be obtained in the first step. Is called the data collection. And data cleaning and pre-processing. So as usual, since it is structured as well as unstructured data, definitely the data will have the mixture of many things. So during the data pre-processing, we will be do some cleaning work, like the noise can be cleaned out, and the unfilled data can be filled out, like some pre-processing techniques which are already we have known, that techniques can be implemented to prepare the data. So, and the data transformation can also be done. Numerical data can be converted into the non-numeric, and non-numeric can be converted into the numeric. It depends upon the need of the data. And here the data quality and quantity are very important. How the data quality? The quality of the data has to be very accurate, and it should be complete, and it should be relevant. For that purpose only we are doing the data pre-processing. In the data pre-processing, we may come into that we can get the somewhat the data quality will be more, and the amount of the data can also be increased by integrating the data sets which we have already obtained from the IoT. And in the second step, so in the first step we have obtained the data is pre-processed and data is cleaned, and now the data is ready for the implementation. And in the second step, we are going to select in which machine learning model I'm going to use for the use of the collected IoT data devices. Sorry, IoT data. So here we know that machine learning consists of the three models: supervised, unsupervised, and reinforcement. And in the supervised means classification, regression; unsupervised means clustering and neural networks can be used. So in my data, what result I want to obtain. So based on my result, based on my decision, which machine learning technique can be used, we have to decide. That decision can be chosen to understand the project objective. That is what project I'm going to do. That is what output I'm in need of, and how I'm going to analyze what type of the data I'm having, whether it's a data or in a structure, and what are the performance required, what predictions I'm going to done from the data. So if we are answering these three questions, then definitely we can identify which machine learning model can be used. So these are all the very common models, as I told in the previous: regression, classification, neural networks, deep learning, time series, etc. So many models are there. So based on my need of my IoT project, I can choose any one of the machine learning model. And in the model training, so the model will be, now it will be trained by the data division, iteration and adjustment. First, I'm going to give the training set. Training and testing set will be given. It will be trained the data, and the model will be identified. If the model is okay, means it will be continuing into the output section. If there is some enhancement is required, then the iteration and adjustment will be done for the betterment. Finally, if I have satisfied with that model, then I have to come into the validation and evaluation. So cross validation technique, it's a very common technique used for the validation, and the performance matrices like these parameters can be measured like accuracy, recall, F1 score for the classification model, and MSE and MAE for the regression model can be used, whether what is the score of these performance matrices. If the performance matrices score is not up to my level of expectations, then I have to go into the backward and I have to do the iterative method to get the more precise value of these parameter matrices. And also, if there is any error, I can identify and analyze where I have committed the mistake and due to which algorithm the error has been occurred. That can also be corrected to improve the performance of the model which I have designed. So these are all the some more adjustments and optimization, how it can be optimized, and what are the technique can be used for the model adjustments can be done. And finally, so now my model is ready for the validation and evaluation. Now I'm going to implement and usage. So once the model is ready, and it will be implemented with the real-time data by making the automatic decision. So model deployment, and we are connecting with the IoT devices. And finally, after implementing, we are going to do the maintenance process, whether it is continuously giving the proper result. Excuse me. So using the model for decision making, process automation, or any customized applications, and for security enhancement can be done. So like in the previous 4 steps, we have obtained the data and we have chosen the machine learning technique which can be used for the IoT data which we have collected, and how it is going to be optimized, or how it is going to be validated, and finally how it is going to be deployed and maintenance. So after that, these are all the benefits. So here we have obtained one model, and that model is deployed now, and these are all the benefits. So it is enhanced the data analysis and pattern recognition, predictive maintenance, real-time analytics, anomaly detection, automation, and personalization, resource optimization, and scalability. So all these are very much helpful, are considered as a very high benefits of integrating the machine learning and IoT. Of course, if we are integrating any two methods, definitely we should face some challenges. So data quality, high conceptual requirement. Of course, data quality and management means we have to get the very precise high quality of the data has to be implemented in the machine learning technique. So for that, I have to obtain the high quality data from the Internet of Things devices also. And the high computational requirement. Here the data is a huge volume of data. The data can be the structured as well as the unstructured data is using. So definitely there will be the computational requirements should be very high, and the security and privacy issues can also be occurred. And lack of the skilled talent and integration with the legacy system. So it's also a very big challenge in integrating machine learning. And of course, the machine learning is nowadays not only for purposes alone, it can also be used in the business also. So the AI powered business strategies. So here AI powered business strategies plays a very important role. So here it is going to get the intelligence choices so that we do not have to. So we cannot expect the data only from the human beings, but the prediction can also be done more. And we are the next one is a predictive maintenance. It is in the industrial settings. So this predictive maintenance has a very less time consuming, and it is a very cheaper if there is any repair occurs. And the future ready prediction can be it is used for the many security issues. If any security issue occurs, future action can be resolved very easily. And a personalized user experiences and finally driving innovations across the industry. So here we have seen how the integrated of machine learning techniques and machine learning with the Internet of Things integrated. Many applications are available. So it is used to improve the decision-making process, and it assists the predictive maintenance and reinforce the IoT authentication. And the many real challenges that this experience include the very poor data quality and high computational requirements and all. So thank you very much for the opportunity given. Any queries? Please you can.
Thank you, ma'am, for your wonderful presentation. Dear participants, now you can ask your doubts, clarifications, or any queries. You can proceed. Participants, you can ask your queries. Participants, you can ask your queries. Bama madam.
Sir?
Yes, sir.
Any queries, ma'am?
Yes, sir, I am having.
Okay.
Good evening, madam. I am Bama Rukmani. Hello, am I audible? Sir, am I audible?
Yes, ma'am.
Madam, you are audible, ma'am.
Yes, sir. Yes, sir.
Uma madam.
Sir?
Bama madam has asked some questions.
Yes.
Yes, ma'am. In real time, how we can apply the reinforcement learning for a particular data set?
Yes, ma'am. The reinforcement learning means by getting the feedback from the environment, so that feedback can be obtained and it can be given as an input to the. Again, it will be given as an input in the input part, and the algorithms will evaluate to get into the output, ma'am.
The possible algorithms that we can use for this technique, ma'am. For supervised learning and unsupervised learning, we are having a specific name. Similarly, for reinforcement learning, which are the algorithms that are frequently used by the researchers.
Bama madam, any more questions, ma'am?
No, sir. No, sir.
Participants, if you have any doubts, you can ask to Uma ma'am.
Ma'am?
Uma madam?
Yes, sir.
in chat box, some participant asked the questions. How to integrate IoT with machine learning?
How to?
How to integrate machine learning and IoT?
Yes, sir. In the IoT data, depends upon the data which we are obtained from the IoT. We can use any one machine learning technique, whether it is supervised or unsupervised. Algorithms can be implemented, sir.
Madam, can you suggest any algorithm?
For which one, sir?
Regarding IoT and ML.
Yes, sir. In the if it is a classification, means we can use a k nearest neighbor algorithm or a navy based algorithm. If it is a regression, means we can use a linear regression algorithm. If it is a clustering, means k means clustering algorithm, sir.
Okay, right. From participants, any more questions? VG Srinivasan, you raised hands.
Yes, ma'am.
Yes, ma'am. Ma'am, in this IoT, you had told that from IoT devices we are collecting the data. That data will be huge amount. For research purpose, you have told that IoT will be integrated with machine learning algorithms. Ma'am, for research purpose, where to get these IoT data? That is, you told that huge volumes of data will be retrieved from IoT devices. No, is it available in the site for research purpose?
Yes, ma'am. It is available in the Google website also. Or if you want to get the real-time data, means we can devise one IoT model, and from the sensor, we can get the real-time data, ma'am.
Yeah, with one data we couldn't able to do it, right, ma'am? We required
Yes,
more amount
the
of
data set
data
is available in
to
the.
train the model.
Yes, ma'am. Yes, ma'am. Yes, ma'am. That's what I'm saying. It is available in the online also. In the Google website, we can obtain a huge volume of the IoT data, ma'am.
But which website, ma'am? Sorry, ma'am.
Google, ma'am. Google.com.
Okay, ma'am. Okay, ma'am.
Ma'am,
Thank you,
ma'am.
ma'am.
Shall I give an answer to you? Shall I give an answer?
Yes, ma'am.
Please,
Actually,
ma'am.
if you want to collect data in real time, that is primary data. Actually, we are getting the data from Google, means it is a secondary data. So we get data as our own based upon our requirements. So then we can collect the data not only with a single sensor. Some sensors can give only one or two measurements or up to 5 measurements. For my research, I need to consider nearly 10 factors based upon the environment. Then I need to deploy more number of sensors and collect the data. It cannot be done on a single day. We have to wait for an year or a month. So for sample data means it is 10 days is enough. We have to deploy more number of sensors and collect the data and make it as a data set. And we need to do some pre-processing and make for our use. Is it okay, madam?
Yes, ma'am. Thank you, ma'am.
Vijay, ma'am?
But it is very
Yes.
cost effective, right, ma'am?
Yes, ma'am. So
Yes,
since we are doing a
deploying
research
more
work,
number of
Yes,
sensors.
since we are getting the data from the sensor, means automatically the cost will be more high.
actually based upon our requirement, we need to deploy the sensors and the field we have to look, identify where I have to collect the data. So that study has to be done prior to collecting the data. And we have also estimate the cost of sensors and the feasibility of using that particular sensors. For that we have to do some basic groundwork. Then only we are able to collect the data in the optimized way.
Okay, ma'am. Thank you, ma'am.
Thank you.
Okay, participants, any more? Any more questions? Okay, thank you, Uma madam. Bama madam, thank you for your views.
Thank you, sir.
Now it's time of vote of thanks. I invite Mr. Jabastin sir, Assistant Professor, Department of Computer Applications, to propose vote of thanks. Jabastin sir.
Thank you, Marimuthu sir. Good evening, everyone present here. It gives me an immense pleasure to express the vote of thanks on this special occasion on behalf of our computer application department. I wholeheartedly thank our college management and our beloved principal, Dr. C. Ashok sir, for giving the opportunity to conduct this ATAL FDP. I extend my heartfelt gratitude to our eminent speaker, Dr. R. Uma, Head and Associate Professor, Nadar Saraswati College of Arts and Science, Teni, for making excellent presentation on machine learning methods and techniques for IoT. Thank you, madam, and making this program more interesting and informative. Thank you so much, madam. It is really informative session. Then I would like to thank our director, Dr. R. Venkatesh Kumar sir, for his continuous support for conducting this program. Next, I would like to thank our coordinator of this FDP, Mrs. A. Agnes Salima madam, co-coordinator Mrs. Alok Kumar sir, for our organizing secretaries and our colleagues. I would like to extend my sincere thanks to all the participants of this session. Once again, I thank you all. Thank you.
Thank you very
Thank
much,
you,
sir.
Jabastin sir. Okay, thank you, ma'am.
Thank you, sir. Thank you. Thank you, madam.
All the participants, session 5 feedback links is posted. Kindly fill up it. After 5 to 10 minutes, session 6 will be started. Kindly wait in Google Meet. Participants, feedback link is available in chat box. Kindly fill up it.
यांना म्हणायचे नाही, यांना पर्सन आवडायचा ते बघा अजूनही म्हणतात त्यांनी जे केलं ना, प्रोत्साहन जे दिलं त्यांनीच दिलं. त्यांना काय आवडत
Participants, kindly fill the feedback form. Okay, participants, session 6 will be started in 2 minutes. Bama madam, it is audible, ma'am?
Yes. Yes, sir.
Okay.
It is audible.
Okay, ma'am. Okay, ma'am.
நீங்க சாருக்கு ஆடியபிளா இருக்கான்னு மட்டும் கேளுங்க.
Hello, Poti sir. Is it audible to you? Sir?
Yes, sir, audible, sir.
Can you start the session, sir?
Yes, sir, sure.
Okay, thank you, sir.
Okay, sir.
Now it's time for session 6. Now I invite Mrs. P. Bama Rukmani ma'am, Assistant Professor, to welcome and introduce our resource person for session 6. Bama madam.
Yes, sir. Yes, sir. A very good evening to one and all. A very good evening to one and all joined in this AICTE Training and Learning Academy sponsored online FDP on IoT data analysis with practical and exploratory approach. On behalf of Department of Computer Applications, Ayanada Janakiammal College, Sivagasi, and on my own behalf, I am delighted to welcome our enlightened resource person, Dr. N. Pothirasan, Director, Hospital Medical, Rajapalayam. Welcome you, sir. I am happy to introduce Dr. N. Pothirasan, sir, a dedicated researcher. Sir has completed his school studies at PACM Higher Secondary School, Rajapalayam in 2009. Sir has completed his BE Electronics and Instrumentation Engineering at JJ College of Engineering, Tiruchi in 2013. Sir has completed his M.Tech in Power Electronics at Kalasalingam University in 2015 and also completed his PhD at Kalasalingam University in 2020. Sir is very much delighted to be an individual worker as well as a team builder. Sir is currently motivating so many students for their career also. Sir has academic tie-up with Kalasalingam University, Krishnangoil and Ramco Institute of Technology, Rajapalayam. And because of his continuous involvement in research, he has received financial support of rupees 70 lakhs from National Science and Technology Entrepreneurship Development Board, Department of Science and Technology, New Delhi, for his various startup projects. So he has around 5 project funds from 10 lakhs to 15 lakhs individually. Collectively, he has received 70 lakhs from me, DST. Sir has acted as a resource person for various workshops. Actually, multiple workshops on the topic PCB design and the embedded system design using Arduino. Sir has also conducted various embedded courses at various colleges. Sir is very much interested in embedded system as well as IoT. Currently, he is providing guidance of embedded projects to electrical and electronic students of Ramco Institute of Technology, Rajapalayam. Sir is also developed the industrial products, namely wet field bipolar cartridge, anterior Victrotomy, endo illuminator vehicle LED light source, chair unit. Today, Sir is going to deliver a session on skill development in line with National Education Policy NEP 2020. On that, he is focusing on advanced biomedical sensor interfacing using IoT. Sir, it's my pleasure to once again register my warm welcome and a heartfelt thanks for joining hands with us to enlighten today's fabulous session. Thank you, sir. Now I welcome you once again.
Thank you, ma'am. Thank you.
Thank you, Bama ma'am.
Thank you, sir.
To make the sessions more useful, I welcome Dr. N. Pothirasan sir to present the topic Skill Development in Line with National Education Policy NEP 2020. Pothirasan sir, over
thank
to
you,
you.
sir. Thank you. Okay, sir. Thank you, sir. Sir, my slide is visible?
Yes, sir, it's visible.
Okay, sir, thank you. Good evening to everyone. So today our topic is IoT database analysis with the practical exploratory approach. So here, first of all, I explain my products. So what are the products making in our company? So the first one is wet field bipolar cat ray. ஸோ ஹியர் அதாவது இந்த ப்ராடக்ட் வந்து பார்த்தீங்க அப்படின்னா உங்களோட ப்ராடக்ட்டில் எங்களோட ப்ராடக்ட்டில் வந்து பார்த்தீங்கன்னா ஃபுல்லாமே ஐ ரிலேட்டட் எக்யூப்மெண்ட்ஸ் எல்லாமே மேனுஃபேக்சர் பண்ணுற மாதிரி தான் அந்த ப்ராடக்ட்ஸ் வந்து நாங்கள் டெவலப் பண்ணியிருக்கோம். ஸோ ஹியர் வெட்ஃபீல்டு பைபோலார் கேட்ரே how did it be works. ஸோ ஹியூமன் வந்து பார்த்தீங்கன்னா இந்த மாதிரி ஒரு ஃப்ளாட்டான பொசிஷன்ஸில் வந்து நம்ம படுக்க வச்சுருப்போம். ஸோ அப்போ வந்து பார்த்தீங்கன்னா அந்த வெட்ஃபீல்டு பைபோலார் கேட்ரேயோட மிஷினரிஸ் வச்சு நாங்கள் அந்த ஐ ப்ரோப்ல.
sir.
Yes, sir.
Sir, it's a national seminar. So other states participants are also participating.
Okay, sir.
Kindly speaking.
Sir, also present in the presentation mode, sir, please.
Yes, sir. You can present in full screen.
Okay, sir. Okay. So sorry for the inconvenience. So this is 5 bipolar electrosurgical generators. This is a Hasan Medicare manufacturing of Catray with wet-field digital bipolar calculator. It is a low power electrosurgical unit. These are my products only. So here it is used for arrested the blood from the blood vessels during the ophthalmic surgery. So this is the about of the product. So here it is electromagnetic surgery is used to roundly it is eye surgery to cut and coagulate and disease and filtrate and shrink tissues. So here I have to given the frequency of high frequency, the 100 kHz to 5 MHz alternating current to various voltage is passed through the tissues generating the heat. So this is our first product. These are the wet field bipolar cat ray. And the second product is LED light source. So this product is mainly used for if your eye surgery purpose. So this is the design and development of endo-illuminator light source. Is surgical tools is used to provide the light for surgeons. This is for basics of my product. These are the products. So this is a LED light source. Here it is if your intensity variations also it is available. Here it is 10%, 20%, 30%. If you given the intensity base, the light it will be come outside with the help of PWM, pulse width modulations. So here I have to integrating for the embedded systems and power electronics equipments I have to place here. And this is the technology of the process of the solutions. Here using the Bluetooth module and better visualization of screen. And specifically we are using the luminous lamp and increment and decrement on operating systems. And generally we are using the halogen lamps. Here it is used for LED light source. The LED light source it will be operating voltage is 5 volt 25 ampere. So here the 25 ampere it will be chopping of the current. If you're like it's like a 10% or 20%, 30%, depending upon the current based this system it will be working. If you're given 10% means if you are operating if your ampere is 5 ampere and if it's 7 ampere, 9 ampere, this base the LED brightness it will be increasing with the help of pulse width modulations. And next product is anti-rototomy. So this product is surgery remove some or all of the vitreous humor from the eye. The anti-rototomy it is mainly it is used for eyeballs. If your eyeballs inside some gels is available, the gel it is removing purpose and replacing purpose we are using for the anterior rototomy. And this is the anterior rototomy of the these are my products. And the last final is vision chart. So the so many opticals and eye based surgery we are compulsory we are used for the vision chart. The most of the people we are using the papers. The more n number of papers we are placed in these room areas. But this type of vision chart it is used for Raspberry Pi. Here integrating of more functions of images it is included to the in your systems. That system it will be if you are integrating of minimum maximum number of languages people it is available in India. It's like Hindi or Telugu. So this type of way it will be people it will be means the vision chart, this vision chart I have to integrate some programs based it will be working. Here it is 11 languages included for the vision chart. So these are my products. So these are the 5 products I have to manufacture here in Rajapalayam. So first of all, first one is wet field bipolar cat ray. This is for eye surgery purpose. If you are any blood vessels are arrested is there means if you are removed that vessels purpose we are using for the wet field bipolar cat ray. So if your normal eye visions we are not used for any lights, so that's why we are used for this light source. Here it is integrating of the one fiber optical cable is insert to the eye. So it is in luminescence, indoilluminator luminescence based, it will be variations of the light source. And the rest one is anti-rototomy, that is for eye ball. If you are like one ball safe, if you are inside the one gel is available, that is gel, it is removed purpose, and insert purpose we are using for the anti-rototomy. The final product of vision chart. So the vision chart, so many papers in available in your room sections. So that is eliminated purpose based is the vision chart I have to manufacture. Here is Raspberry Pi model. Here integrating the Raspberry Pi model, we are insert the memory card. I have to given the more images. If your children's, it will be, if like children's, it will become in your eye surgery purpose. It is interesting for any animal based images, it will be displayed. So these are the product manufactured in Hassan Medicare. So here I have to manufacture PCB designing and resistor, capacitors and inductors and so many ICs I have to integrate for this in these systems. So these are the product is manufactured in this session. So basically you are going to the embedded system and power electronics. If you need a miss, the types of components is very important. The first one is resistor and inductor and capacitors and LED and IC555 timer and 9-volt battery and 7805. So this is the basics components of types of components is available in India. The most of the components is available is basically important components is first one is resistor, capacitor, inductor and LEDs and 555 timer. So this is the resistor. The resistor is an electrical component that limits the flow of electrical current. The resistor is the ability to reduce the current is called resistance. This the resistance is like a ohms. The symbol of, if you like, the ohms. So here the resistors, the color code you have to find first digit. If you BB Roy, great bidon and very good wife, this is based only the color code, it will be found for the resistor. But the theoretically you are studying the resistor just on lines if you have placed it, but practically many of the resistors is available with like a watts based or size based. If you are here, it is 0.25 watt resistors, means if you are very small amount of watts it will be consuming. So here it is 4 band and 5 band and 6 band. There's so many resistors is available, but theoretically you have to study for 3 band resistors only. Here it is placed for 4 band and 5 band and 6 band. So depending upon based BBRI, great bidon and very good wife, that based it is resistor, it will be calculate. The watts also it will be calculated for the P is equal to V and I. This is a resistor for these are the resistor based the color code and wattage of resistor, it will be find it. The next one is inductor. Now, inductor is also called the coil and reactor. This is the passive terminal to terminal, the electrical component which resists the change in electrical current passing through it. So the inductance, it is mainly used for this one ferrite rod. If you are round shape, here it is the right. This is called the ferrite rod. Here I have to place it for this one inductor. Is like a coil. So if you wind out the coil, if your LCR meter, if you find the LCR meter, it will be find the microhenry or millihenry. So depending upon your research based, you have to find this value for the inductance. So that is reduced per Henry. And the next one is capacitors. These capacitors were electrical component in the passive two terminal electrical component used in the stored energy. The capacitors are widely used in electronic circuits while blocking the DC current while used in the AC circuits. If you are the capacitor, the two types of capacitors available. The first one is electrolytic capacitor, another one is disk capacitors. And this is for the LED, the light emitting diode. This is a semiconductor light source. Here it is indication purpose we are using for the LED light source. LED, but here it is LED operating voltage is 2 volt 20 milliampere. So if you are different colors is available in market, so depending upon your product based, you have to place for these LEDs. And this voltage regulator IC, this IC is 70 series 8 plus voltage. You need, if you're in your hand, you have 9 volt input is available, but you need 5 volt, but this IC it will be converted for this 5 volt. So that is the purpose we are using 7805. 8 means plus voltage, 05 means 5 volt. If you needed some op-amp ICs, we are integrating for both power supply and positive power supply and negative power supply also. So that's why we are using the positive voltage regulators and negative voltage regulators. So 7805 means it is getting for this positive voltage, positive power supply, and negative voltage if your regulators means the 7905 it is getting for negative power supply. If you are getting 5 volt, you have to given the minimum input of 7.5 volt. So if you taken in your hand 9 volt, if you're getting 5 volt, it is very easily. So this type of IC, it will be integrating for maximum power supply purpose we are using for these circuits. And next, if you are small circuits, I have to integrate in Proteus software.
రెడ్ పెన్ ఎందుకు ఇప్పుడు కొత్త చేసే పెన్ వాడాలా పాత పెన్ లేవా పెన్సిల్ తీసుకురా చిన్న పెన్సిల్
So example we are using the one Proteus software simulation purpose. So this is a cracked software only, this one. So first I have to place for this one LED blinking. So I need what are the components I need? I have placed here. The first one is I need 555 timer. So 555 timer I taken here 555, and next one is I need battery. So that I have to select for the DC voltage source, and next I need a capacitor. So here I will select for the capacitors. I need electrolytic capacitor. So that's why here I will select for electrolytic aluminum. So select I own capacitors. And next I need resistors. So here the many wattage of resistor is available. I need 0.6 watt. Any resistor I have to select it here now. Next one I taken for LED. Many colors of LED is available in here. I taken for red color LED. So the remaining parts I will place for in front of front panel. So this is 555 timer IC. Here 8 pin is available. The first pin is ground. So I take ground. Here I will place it. The first pin is ground. The second and the sixth pin it will be short. And 4 and 8 pin it will be short. So this circuit is available in internet. So the same manner, these all the circuits, it will be working fine or not. It will be checking. This software is very helpful. So here I will integrate for this one capacitors. Capacitor positive it will be connected to the second pin, and capacitor negative it will be connected for the ground. Next I will taken for the resistors. So here I will place it. So this circuit is just LED blinking circuits, this one. So I need one 555 timer IC and 2 resistors and one capacitors and one LED. So these are the components is needed for the LED blinking purpose. So that pin I will connect for one LED. Finally I will connect for this ground. So I will change the resistor value. And next one is resistor 2 value is 1K. So this is formula based only. This value it will be calculated is possible. Here I will place for 2.2 microfarad. So this one is a 555 timer IC, and this is for the resistors, and this is for the resistor, and this one for a capacitor. This is electrolytic capacitor. Here positive terminal is there and negative terminal is there. So here it is third pin. It is connected for this one LED, and finally I will connect for one battery. The battery it will be connected to 4 and 8. This one I will connect it for the ground. Now run the simulations. So now the LED it will be blinking, right? So here, if you go for IoT, the power electronics is very important. So here, what are the components is there in your hand? What are the circuits is available? How it will be work on these circuits? This is not integrating for any programming. Just IC based only this system it will be working. Here one is a 555 timer. I will place it, and 2 resistors and 1 capacitors and 12. So here I will change the capacitor value. Here I will change the capacitor value 2.2 microfarad to 10 microfarad. So now the LED blinking waveform it will be different. It will be take more time. The on time also it will be different, and off time also it will be different. So here you have to attach for an oscilloscope. That oscilloscope A pin connected to the third pin. So now turn on the LED. So here oscilloscope same channel, 3 channel I will turn off. Or A only I will connect here now. So here I will select for the DC, and frequency also I will adjust. So this is timer based. How much percentage it will be on and off. The PWM pulse it will be displayed in digital oscilloscope. So this is a basic circuits. If any circuits you have to place it is here, it is possible. Here the LDR and if you are touch switch, so many applications we are used for the Proteus softwares. Here I will place I will place here. This is touch switch. So this is for the touch switch. You have to up and down button arrows is there. Here you have to touch it. It is possible. And next one is LDR, light depending resistor. So here the LDR, the light based also it is available. So this is the LDR, another one. So here the sound light waves you have to in front of, if a light waves it will be applying means the LED will be off. You come backside means the LED will be on. So this depending upon based the circuit will be working. So next we are going for the IoT. The IoT is very IoT platform. It is very important for Arduino Uno board and ESP8266 model. So we are integrating Arduino microcontrollers. We are interface for 0 to 13 digital pins are available, and A02, A5 analog pins are available, and on 5 volt on ground. And the serial data and the serial clock, I2C purpose, SDA and SCL. So these are the pins are available. Here you have to. So this is the Arduino board. So here one 3.3 volt and 5 volt ground, and A0 to A5 analog pins, and 0 to 13 digital pins on ground, I2C inter-integrated circuits, and SDA and SCL, the two pins are it will be connected to the inter-integrated circuits. You have to given the USB cable, that is a programming purpose. And this is for this if you are given external power supply of 9 volt, it will be converted to the 5 volt. Inside of the IC is ADMEHA 3 to 8P. This IC you have to integrate embedded C programming with the help of Arduino IDE platform. So you have to return the program, dump it. If any ideas, if you there means if you return the program, if you place for external devices, you have to connect means the bulb it will be on. So the previously I will show for an IC 555 timer without programming, the LED it will be on. So this is the only you have to return the program only, that Arduino it will be working fine. So here the number of sensors is available in market. The first one is real-time hardware implementation of GSR sensors. This is based on galvanic skin response. These biomedical sensors. So if you are these sensors, it will be mainly used for home patients. If you place it in your wear for the fingers, if you touch the resistance value, it will be increases. At the time the Arduino it will be getting the signals. The buzzer it will be turned on. So which time he will otherwise nervous person is there. So which time nervous time it will be taken for this type of galvanic skin response. So it will be find out for this resistance value. So if you need suggestions for any other, you are drinking the water, otherwise you go for walk. So this type of way we are implement this project for the real-time hardware implementation of galvanic skin response. And this is for SpO2 sensor. This is for real-time hardware implementation of SpO2. The SpO2 means if this sensor it will be mainly used for blood oxygen level and human heart rate. So you have to, this is for I2C circuit based this sensor it will be used. This sensor name is Max 30 and Max 30 1 or 2, that sensor also it is available. But this SpO2 sensor is mainly used for to find this heart rate and blood oxygen level. If recently it will become like this smartwatch, this type of sensor only it is available in your smartwatch. So with another microcontrollers placed in your systems, but this if your project purpose we are using Arduino Uno board. That Arduino Uno board you have to return the program of embedded C programming. So you are connecting for the 4 pins. One is 5 volt and ground and SDA and SCL. SDA means serial data and serial clock. So we are connecting for the 4 pins. We are getting this output of human body. If that sensor it is placed for in your human body, it will be find out for human heart rate and blood oxygen level. And next sensor is DHT11 sensor. This is called data humidity temperature sensor. This sensor is mainly used for if you are if you are in your this system, it will be mainly used for atmosphere temperatures and humidity it will be find out. The sensor it is placed in your body, the body temperature and humidity it will be find out. The incubator you are placing for this type of sensor also it is possible. DHT11 sensor. This is positive temperature only it will be find out. It's like a 0 to 100 degrees Celsius. If your negative temperatures also it is needed means DHT22 some sensors are available. And this is for IR sensors, the real-time hardware implementation sensor for IR sensors, where IR sensor 3 pins are available. The first one is 5 volt and ground and data. The 5 volt is connected to the Arduino 5 volt and ground is connected to the Arduino ground. The data pin your base, if you are depending upon your program, you have to return base you have to place for the pins. And next, this sensor is mainly used for obstacle avoidance purpose. We are using for this IR sensor. If any obstacle in front of this IR sensor, at the time the buzzer it will be on. Otherwise, the LCD display, the obstacle is detected, that it will be so. That is the purpose we are using for these IR sensors. And real-time hardware implementation interfacing of ultrasonic sensors, that it is mainly used for blind peoples. So if that blind peoples in front of, you have to place for this ultrasonic sensor. Any other obstacles or any walls or any at present any obstacles is presented in your systems, the buzzer it will be allowed. So that is the purpose we are using for this ultrasonic sensor. So this ultrasonic range is 0 to 400 centimeters it will be detected. And next one is gas sensor, the real-time implementation of interfacing of gas sensors. So if you are threshold based, this is for analog sensor and digital sensor also. So we are connecting for now analog pins. So these are the here 3 pins are available. One is 5 volt and ground and analog A0. So if this real-time hardware implementation sensor with the gas sensor A0 pin I have to connect it now. If you are getting the value of, this is 8-bit microcontroller, the 2 to the power of 8. If you are calculating the 1023 values, so here I will connect for this analog sensor. So that's why it is finded for 0 to 1023 values. So in if you are 500 greater than threshold value, you have to find it. If you are in your home appliances, we are integrating the sensors. Now if you are turn on the gas, at the time the threshold value, it is easy to, you have to find it. If you are 500, example, if you are 500 is threshold value, the 500 above is the gas is detected, the 500 below is the gas is not detected. So this type of way we are using for this type of sensor, the gas detector sensor. And this is for the servo motors. It is mainly used for robotic arm purpose. We are using for the servo motors. The servo motors, it will be rotating for 0 degree, 90 degree, 180 degree and 45 degree. So depending upon your angle based, the servo motor will be working. There is a simple example, the dustbin it will be automatically opened with the help of IR sensor. In front of IR sensors, the dustbin it is automatically working. That is the purpose we are using for the servo motors. And gate open and close, and so parking slots, gate open and close, that is the purpose we are using for the servo motors. And the next one is internet of, this is basic idea of how to interface the sensors. Next one is internet of things. One things it is connected to the internet, and another one, your mobile phone also it is connected on internet. The two internet it will be paired, at the time the data it will be displayed. So example, so here the Proteus software, the same integrating of some sensors also it is possible. This is Proteus simulations. Example, I will taken for one LED blinking. So in the software, an Arduino microcontroller also is there. This is Arduino microcontroller, the virtual Arduino microcontroller. Here interfacing 0 to 13 digital pins are available, A0 to A5. Here I will connect for one LED. LED pin I will connect. I will connect for 13th pin. So I have to return the program now. This is LED blinking program. So this is LED blinking. So here I will place for this integer LED equal to 13th. Void setup pins, the pin mode LED comma output. Void loop is LED pin comma high 1 seconds, LED comma low 1 second. So here the return the program is 1 second on, 1 second out. Now compile the simulations. So now I will select the board, tools, board. I will select Arduino board. So next I will compile this program. So I will connect here, I will mention the 13th pin. So that's why I will connect it to the 13th pin of LED. So you are mentioning 12th pin means here you have to connect the anode, the LED anode, you have to connect the 12th pin. Right. So here I will place for 13th pin. Void setup function is what are the pin input, what are the pin output. That is the purpose we are using for the void setup functions. So here the LED is output. So that's why LED comma output. Void loop is LED comma high 1 second, LED comma low 1 second. Now compile the simulations. So here I getting a hex files. So this is our hex file. Just copy the hex file. So I pasted in Proteus software. Now run the simulations. Now LED it will be run on 1 second on and 1 seconds off. So next simulation is LCD display. So we are integrating the LCD display. So this is for LED blinking output. Here now it is a LED, it will be 1 second on, 1 second off. Yes, continuously it will be running. So why it is continuous means if I have to place the program in void loop functions, so that's why the LED it will be continuously running. So next program is LCD display. So here I have to integrate for the LCD display diagram. So here I taken for one Arduino Uno board and LCD display. This is Arduino Uno board. This is for brightness, for LED brightness purpose. We are using one potentiometer. This one you have to taken for pod HG. If it type means this type of potentiometer will be getting. Next one we are using LCD display 16x2. So here the 16 pins are available. So here it is mainly it is connected to the Arduino RS and enable and D4 and D5 and D6 and D7. So here the RS pin is connected to the 9th pin. So here the RS pin is connected to the 9th pin. So this is the LCD display plus Arduino integrating of circuit diagram. So we are integrating the on potentiometer. This is for LED brightness control purpose. The RS pin is connected to the 8th pin. The enable pin is connected to the RS pin is connected to the 9th pin. The enable pin is connected to the 8th pin. D4 is connected to the 5 and D5 is connected to the 4 and D6 is connected to the 3 and D7 is connected to the 2. So these are the pins I will connected for the LCD display 16x2. The many display is available 20x4 and 16x4 and 20x2. So here it is connected for 16x2. So here I have to return the program of LCD display. So this is the Arduino platform. So here I will place for as include liquid crystal.h. This is for the library files. So the here it is constant integer RS equal to 9. So if here I will connect the pin is RS is connected to the Arduino. Once again I will explain here now. This is here the RS pin is connected to the 9th pin and enable is connected to the 8th pin. D4 is connected to the 5 and D5 is 3 2 4 3 2. So this type of way I will connect it. So that's why I will return the program also. Here I will mention RS equal to 9 and enable equal to 8 and D4 equal to 5, D5 equal to 4, D6 equal to 3, D7 equal to 2. The LED liquid crystal LCD, this is a function of RS, enable, D4, D5, D6, D7. So if here void setup function, the LCD dot behind 16,2. Here I have to use it for 16x2 LCD display. That's why I will base for 16,2. The void loop function, we are using the some functions. The LCD dot clear and LCD dot clear, LCD dot set cursor 5,0. The fifth place the Hasan it will be display and 0th position and Hasan that the name it will be printed. Next one is LCD dot set cursor 2,1. Here it is display for Medicare. So depending upon 2 seconds delay and LCD clear and say again it will be display. The first 2 seconds the Hasan Medicare it will be display. The second 2 seconds the Rajapalayam and I will change the name Sivagasi. Okay, so this type of way name I will place here now. So the first one name is Hasan Medicare, depending upon 2 seconds delay and LCD clear. Again 2 seconds it will be display for Rajapalayam and Sivagasi. Now I compile the simulations. Here I getting the hex value, hex file. Here I getting the hex file. So now I will place for this LCD display functions. So here insert for the program file of hex file. Now run the simulations. The first, it is displaying for Hasan Medicare. The second 2 seconds, it is displaying for Rajabalayam and Sivagasis. First one is Hasan Medicare. Fifth place, the Hasan it will be displayed. And Medicare is second. 2,1 I have to place. That's why it is Medicare downside will be placed. Delay 2 seconds. And again it will be LCD clear. It will be so for Rajabalayam and Sivagasi. So any name if you are displaying purpose, otherwise if your sensor data it will be throw in your LCD display. This function is very, this coding is very useful for this your LCD display 16x2, it will be connected to the Arduino. And next I will connect for these sensors. And next simulation is we are integrating some sensors. So now I will connect for this LM35 temperature sensor. So here I have to place for this LM35 temperature sensor and Arduino Uno board. And this is for Arduino Uno board, and here I will place for one LM35, and here I will integrating for terminal box. So here I will return the program of Arduino programming for LM35. So this is the Arduino programming of LM35. The same temperature pin is I will connect for A2. So here I will connect the temperature is A2. So that's why I will mention the pin of A2. The temperature data pin is connected to the A2. The temperature sensor, 3 pins are available. The first one is 5 volt, another one is ground. This is 5 volt and this symbol is ground. This symbol is ground. The data pin is connected to the A2. This is for the virtual terminal box. So if your temperature sensor real visible is not possible, so that's why what is the value there in your LM35 temperature sensor, in terminal box it will be displayed. Okay, so here I will return the program of LM35 temperature sensor code. This asked event temperature sensor is A2 that I have to taken for the integer temperature value. The void setup functions, the serial monitor I have to use on it. So that's why serial.begin 9600. This is for baud rate. And void loop functions, we are getting the temperature value equal to analog read temp pin. And I need two type of values. The first one is Celsius, another one is Fahrenheit. So that's why the float value it is I need very important. Why mean the human body temperature is 37.5 degrees Celsius. So that's why it is float I have to mention. Float means its point value it will be getting. And this is the formula of temperature degree Celsius, and this is the Fahrenheit of formula. This one is temperature Fahrenheit and this one for temperature degree Celsius. These two values it will be displayed for in your serial monitors. So that's why we are using here it is serial print. Temperature is degree Celsius and temp cells and degree C, and this is for the second one is temperature Fahrenheit degree Fahrenheit. So these are the functions. Now I will run the simulations. I have to select the board of Arduino Uno. Now compiling the Arduino IDE platform. So here I taken for the hex file. So here I will place for this in a Proteus simulation software. Here programming file I will change for the hex file. Now run the simulations. In the terminal box it will be displayed. Here degree Celsius also it will be displayed. Fahrenheit also it will be displayed. So here I will set the temperature is 27 degrees Celsius. In real time we are connecting the sensors, it will be getting the real time value. But in simulations we are not getting simulations real time value. So that's why here increment and decrement button is there. I will change the temperature range value. So here it will be displayed. Now the 24 degrees Celsius, approximately it will become like this 23.93 degrees Celsius. So in real time, automatically it will be changed for the temperature degree Celsius and Fahrenheit also. So here it is, I increase the value. Now the temperature value also it will be increasing, degree Celsius and Fahrenheit also. So this is for the temperature sensor working principle. And next one is we are integrating next sensors. Next one is IR sensors. So this IR sensor we are integrating on Arduino microcontroller, and IR sensor we are connecting 3 pins, the 5-volt, ground and data pin. So externally I will connect for this virtual terminal box. So how will we detect the obstacle in virtual method? Here it is 1 means the obstacle is detected. This here 1 means it is in front of my obstacle, any hand or any obstacle present in two LED IR LEDs. So here 1 means the in front of IR, if you are any some people, otherwise any present is there. If you 0 means is not present. Here not present any obstacles. Okay, so here, that's why here connected for the IR sensor. This is 3 pins I will connected for the Arduino microcontrollers, and data pin is connected to the 3rd pin, and the output pin is connected to the 4th pin. So we are checking if you are practically virtual methods, we are checking for this type of terminal box logic toggle. This one, if you detect 1 means the obstacle is present, if you detect 0 means obstacle is not present. So this is the terminal box and an IR sensor model, and this is for the test pin, and here it is connected for this logic toggle, and finally it will be getting output. So the obstacle present means the LED will be on, obstacle is not presented, the LED will be off. So here I will return the program next. So here I will use for as include wire this library file. So I taken for 2 pins. The IR sensor is input sensor, so that's why I will place for pin mode 3 comma input. The LED is output. The 4th pin I will connect for LED, and the serial dot begin 9600 is here it is checking for the serial monitor value. Wide loop functions, the long value equal to digital read 3rd pin. IR sensor I will taken for digital sensor, so that's why he will place for digital read 3rd pin. So that value it will be show in your serial monitor. If your IR is present means if the value it will be stored in your value, that like I will mention for val. If val equal to 1, at the time the LED it will be on. So at the time present also the serial monitor also it will be presented, obstacle is detected, and at the time the 4th pin also it will be high, else digital write 4 comma low. In serial monitor it will be so in obstacle is not present, not detected. So this is your wish. So depending upon your application based, the serial print in it will be varying. So here the 3rd pin is input and 4th pin is output. The while loop function we are using for the value equal to digital read 3rd pin and so in your serial monitor. And if your value equal to high, at the time the LED will be on. Below mention also the serial printing mention also obstacle is detected, else the LED will be low, obstacle is not detected. So now run the simulations. Now run the simulations. Here getting the hex file. Wait. So here getting the hex file. So we are here interpreting for one IR sensor model. That programming hex file I will place for in programming file. So this is simulation purpose. We are compulsory. We are placed for hex file to here library file also. So the two hex file is presently is completed. Now run the simulations. Here it is come like this 0. So that's why the obstacle is not detected. So now presented the 1. 1 means the obstacle is there in front of IR sensors. At the time here it will be display for obstacle is detected. At the time the LED also it will be turned on. The LED pin is connected to the 4th pin. The IR sensor is connected to the 3rd pin. The 3rd pin is input and 4th pin is output. Next I will connect for this IR sensors. Here the test pin. But practically how it will be checked means here in front of two IR LEDs before placed in your hand or any other nodes. If you place in your in front of in IR, at the time the obstacle is presented. Otherwise obstacle is not there means obstacle is not detected. Now I change the zeros toggle values. It is showing for obstacle is not detected. Okay, this is the working of IR sensors model. So next sensor is gas sensor. So here I will connect for the digital sensors. This one also same. VCC and ground and data. The data pin is connected to the 5th pin and the 7th pin is LED. So here it is connected for the test pin. This is for testing for gas is detected or not. So if you are present 1 means the gas is detected. If you are interested in any gases or LPG gases or outside any chemical gases also, if you are getting the threshold value, based the LED will be on and buzzer it will be on, or LCD display it will be show some other words. So that also it is possible. That also it is possible with the help of Arduino and the gas sensors and the resistors and on LEDs. And next one is so many type of Proteus simulations are available, but the time is very short. So that's why I will show what are the simulations is available. And the next one is L298N motor driver model. So this is for robotic chase vehicle purpose. We are using for the L298N model. So here integrating of one Arduino microcontrollers and one L298N model and two motors. So here integrating of 12-volt power supply. If you are directly connect to the motors, it is does not run. Why means the each pin it is delivering for 40 milliampere only. So that's why we are using for L298N model. This is motor driver model. Here integrating for these two motors. These two motors. So these functions I will integrating of now. So here I will use for this L298N code. So here I will run the code. I need 4 pins. Each motors it is connected to the 2 pin. The first motor purpose we are integrating for motor pin on 1 and motor pin 2. The motor pin it is connected to the 5th pin and the second pin is connected to the 4th pin. The second motor 2 pins are available. The first pin is connected to the 3rd pin and second pin is connected to the 2nd pin. So here void setup function, all the motor pins are it is connected to the output. So that's why here it is motor 1 comma output, motor 2 comma output, motor 3 comma output, motor 4 comma output. In loop function, here what are the programming it will be functioning here now. The motor pin is low. The first motor 1 and 2. The motor pin 1 and 2 low high means the motor it will be rotating forward directions. A second motor 3 and 4. Second motor also it will be rotating forward directions with a timing of 2 seconds delay. If you have 2 seconds delay at the time the two motors it will be rotating forward direction. Next I have to return the program of The first motor is 1 and 2, motor pin 1 and 2, the first motor. High low. High low means the motor will be rotating reverse directions. Okay, 3 and 4, it is second motor. The second motor also it will be rotating reverse rotations, and with the timing delay of 2 seconds delay. And again it will come like this stop position, all it will become like this low. Two motors, 4 pins, it is connected to the low only, so that's why the motor will be off. So this code, what it will be function of, the first first one is motor, it will be rotating forward directions, and second one is if we have 2 seconds delay with the help of reverse rotations, and 2 seconds the motor will be stopped. This function based the motor will be rotate. The first two motors it will be for rotating a forward directions in 2 seconds, and second line return the code of 2 seconds reverse rotations and 2 seconds stop conditions. This continuous if you're placed for the loop function, so that's why continuous pace it will be rotate now. So here it is select for the Arduino Uno board. Now run the simulations. Here getting the hex file. So here I will place for this Arduino coding to program file. So here I will place for on Arduino microcontroller. This is for L298 driver module. This is L298 driver module. Here I will connect for first motor, and this is for second motor. Each motor it is 2 pins are available. This motor it is forward. This for 2 pins and this for 2 pins. So that's why I will connect for the 4 pins. Now run the simulations. First 2 motor it will be rotating forward directions with a 2 seconds delay, and again it will become reverse rotations. 2 seconds delay and 2 seconds the motor it will be stopped. So again I will show you in big screen. Now the motor it will be rotating. Now the stop position, again it will become like this forward rotations. 2 seconds delay, the forward motor it will be rotating forward directions. Again 2 seconds it will be reverse rotations, and 2 seconds stop. So this type of way you have, if you are simulating purpose, this software is very useful. So if you are purchasing hardware, if you are connecting wires problems, or this type of way it is not possible to do in your simulation software. It is very helpful to integrating of microcontrollers and driver boards and sensors. If you previously you have to check, and if you definitely if you purchase for the hardware, if you integrating some sensors, it is getting output is very easy. Okay, next simulation is next simulation spot. PIR sensors. Just I will show you. Not run the simulations. So this is the PIR sensors and Arduino microcontrollers and LEDs. And next sensor is relay module. So we are integrating the home appliances purpose. We are integrating the relay module. So here one Arduino and one relay and 12 volt external power supply, NO common NC. So here it is connected for one batteries and bulb. And next was soil moisture sensors and servo motor. So here integrating the Arduino microcontrollers and servo motors. And next one is soil moisture sensor. So this is soil moisture sensors and one Arduino microcontroller and one virtual terminal. So this is for analog sensors. So many sensors, if you are integrating the Proteus simulations also, it is possible. Unless I go for PPT. So this is Internet of Things. We are compulsory. We are used for the Internet of Things purpose. Node MCU microcontroller. This Node MCU development function. 1 minute. So why use for IoT? The organization in variety of industries are using the IoT operate more efficiently and better understand the customer to deliver the enhancement customer service and improve the decision making and increase the value of business. The IoT ecosystems. So these are the IoT gateway and edge devices. We are integrating the cloud. So that is the purpose. These are the ecosystems also. It is used benefits of IoT to monitor the overall business process and improve the customer experience and save time and money and enhancement employee productivity and integrative adaptive business models and make better business decisions and generate the more revenue. And this is the use of IoT and consumer and enterprises of IoT applications. And practical, I will show you. So the practical implementation purpose, where real-time boards are available, Node MCU microcontroller and ESP32 microcontroller and ESP32 CAM microcontroller and a Raspberry Pi model. If you are Raspberry Pi 2, 3, 4, 5, so this type of model it is available now currently in Arduino microcontroller plus ESP8266. So we are integrating Arduino microcontroller compulsory Wi-Fi purpose. We are using a external board of ESP8266. If you connect only if you're getting a Wi-Fi, you have to connect the Wi-Fi. It is getting the data in your cloud also. It is possible. And next one is introduction of Node MCU microcontroller. The Node MCU development board is featured Wi-Fi capability and only one analog pins and digital pins are 8 digital pins are available and serial communications protocols also it is available. So this is it is fully for IoT purpose. This board it is mainly used it. So here it is write the programming and Node MCU development boards it is write the program and in the same manner you have to connect some sensors and integrating of power electronics model is like a relay or MOSFET driver board and IGBT driver board. This type of board you have to connect and get these outputs. So there are online Node MCU custom builds are available using which can easily get our custom Node MCU framer as per requirement. So this is the pin diagram of Node MCU microcontroller. Here one analog pins are available. The many digital pins are available, and RX, the DX, the digital pins are also it is available. The example, the real-time hardware implementation of IoT, we are integrating the Node MCU microcontroller and one resistor and one LED. So here it is checking for on mobile phone. You have to create the one applications with the help of Blink or Firebase and AWS. Many database are available. So here you have to return the program in Node MCU microcontroller. If you are creating one applications, just on and off. If you press the button on means the LED will be on, off means the LED will be off. And next this type of one real-time hardware implementation of multiple bulbs and fans and your home appliances, the many devices you have to connect it to the relay with the help of Node MCU. So here the Node MCU operating voltage is 5 volt. The external power supply if you given for high link, one power supply is available. The high link you have to connect it to the Node MCU microcontroller. If you 230 volt to 5 volt it will be converted. Here it is connected for the Node MCU microcontroller. The many digital pins are available: D0, D1, D2, D3, D4, D5, D6, D7. So here it is connected for these 5 relays. So external side you have to connect for more number of devices like bulb or fan or AC. So maximum 5 ampere. If you given 5 ampere load, it will be relay. It is possible. If you needed a maximum number of ampere means if you change the relay, here I will connect for 5 volt 5 ampere relay. Here it is if you are sometime AC if you connect means the 16 ampere or 30 ampere relay it is available. 5 volt 30 ampere it is connect means just if you create one applications if you just on means the bulb it will be on with the help of IoT. Any places you have to control it is possible. You are there in Chennai but your devices there in your home, or otherwise it's like a Krishnan Govil or Star Rajapalayam. So just if you click on means the bulb it will be on with the help of Node MCU microcontroller. The Node MCU microcontroller is connected to the one Wi-Fi model. Your mobile phone is Wi-Fi model. The two internet it will be paired. So here it is compulsory is needed in devices. Is an example. I am there in Rajapalayam. So this devices is connected to in my office. So here it is connected for these 4 devices on bulb, fan, and AC, and otherwise if you are a night lamp. So these are the 4 devices are connected for this my office. So I am there in now Chennai. So that's just I have one application is there. Just to turn on means the bulb it will be on. It is if you are communicating for this via IoT. So this type of way, this type of mode is very useful, and this is real-time hardware implementation of LCD display. This is for the virtual LCD display. This virtual LCD display, if your sensor data, you have to find the sensor data. Otherwise, if you are any sensor integrated in ultrasonic sensor or gas sensor, otherwise a visitor counter purpose. So the many of the applications you are show in your mobile phone also. So if the sensor data, it will be show in your mobile a virtual LCD display. So these applications you are creating for the blink applications, we are connecting to the Node MCU microcontroller. Your Node MCU microcontroller, we are integrating some sensors, ultrasonic sensor, IR sensor, gas sensor, motion sensor, any other sensor. What is the status of in that present in Rajapalayam? You have to see it is in Chennai also. It is possible with the help of this application based. And temperature, the same temperature and humidity also it is monitoring to in your mobile with the help of Node MCU microcontroller. That Node MCU microcontroller Wi-Fi integrating of Wi-Fi model is available. That's why it is connected to one internet is connected to that device. It is so in your mobile phone. Any places this a simple example, we are integrating the sensors in our agriculture field. It is placed for this type of systems on Node MCU and a DHT11 sensors. So we are getting the 2 data. The first one is temperature and second one is humidity. So we are there in Rajapalayam, but you are seen in your Chennai also, in land in Rajapalayam, but you are seen in Chennai. So that what is the temperature in there in our field in Rajapalayam. So it is pointed for this temperature value and humidity value. So that is the manner. You have to click on one button, just on means the water it will be providing for these seeds. So that's this type of way also it is including it is possible to with the help of Node MCU microcontrollers. And the same manner it is connected to the ultrasonic sensor. This ultrasonic sensor mainly used for water level indicators. If you place the sensor in water tank in upside, the water it will become upside. At the time the motor it is automatically turn off. If you are correctly turn off or not, it is checking for in your mobile with the help of via IoT. So that is the purpose we are using for the ultrasonic sensor. Otherwise the blind people is there, if you in front of your place for the ultrasonic sensor, any obstacle present in there, if you otherwise if you fall down for the people, it will be find out for this type of sensors. If we are intimate the GSM model and GPS model to integrate this type of model, it is sending the data to authorized persons. So that also it is possible for real-time hardware implementations of ultrasonic sensors. This is a gas sensor. The gas, how much percentage of threshold value in there in night time. So night time that so many people is not working. It's not possible in lab experiments. So if you are presently, I will price for this type of sensor. Any leakage of sensor. Otherwise, if you are in this room, the gas value it will be very high. So automatically turn off in your systems. That is a purpose we are using for the gas sensors. And IR sensor, this is obstacle purpose. Otherwise medicine counter purpose also we are using for this type of sensor. The many of the old age peoples and many peoples are available. So many old age peoples, otherwise any physically challenged peoples, we are getting the medicines is present or is there or not, is not does not checking. So that's why we are using for this IR sensor. If you taken one by one, if you show the IR sensor, if your remainder count, it will be show in your display. Otherwise, any authorized persons, it will be getting the app that if you are, it is find that it is minimum 5 medicines only it is available. So it is purchased. Taking alert also, it will be sent to in your mobile with the help of via IoT. And the servo motors, the robot functions. If you are forward, if your robot hand or leg So that is the purpose we are placing for the servo motors. It will be moving forward directions and reverse directions and right directions and left directions. We are the functioning for real-time hardware implementation of this type of servo motors is possible. So here it is 0 to 180 degree. The servo motor it will be rotate 0 degree, 90 degree. Depending upon your application base, you have to return the code. The servo motor it will be rotate. So here it is. So next, the IoT platform. This type of board is very important for the ESP32 microcontroller. This microcontroller, it is mainly used for 32-bit. This microcontroller is the 32-bit microcontroller. Here, inbuilt Bluetooth and Wi-Fi model also it is available in ESP32 microcontroller. Many digital pins and analog pins are available. This comparing with Node MCU, the ESP32, the many GPIO pins are available, and ADC and analog to digital converters. But Node MC microcontroller, only one analog pins are available, but this ESP32 many analog to digital pins are available, and here it is SPO. If your many features are there in ESP32 microcontroller compared with Node MCU, so the both are same function only, but single sensor you are integrating the Node MCU is enough. Many sensors you are integrating, you are going for ESP32 microcontroller. This microcontroller, many GPIO pins and serial data and I2C model, SPA, peripheral interface. So many of the pins are available. So here it is integrating for one heart rate sensor. If you find the same IoT manner, it is connected for the 3 pins, 5-volt ground data. The data pin it is connected to the 36. Any pins you have to choose it, but this is PWM pin only. It will be working for the heart rate sensors. So here it is checking for the heart pulse. It is how much heart pulse is now presented is there. If you are accurately means 60 to 120 the human heart rate. If you're below it will be K means it will be alert for the human. If 120 above it's going means the alert for the humans. If you place that watch, if you create the one watch, if you place for the ESP32 microcontroller and a heart rate sensor, so every time you have to find for this heart rate level. And next one, this sensor is DS18B20 sensor. This is temperature sensor. This one waterproof temperature sensor. If you find any water temperature, so that is the sensor is very useful. But this sensor is completely connected for 5-volt, 3.3 volt ground, and one 4.7 full up resistor. If you connect only that sensor, it will be getting output. If you directly connect to the data pin means it's not getting any outputs. So that's why I presented for in some temperature sensor I will place for one full up resistors. And here you have to integrate for ESP32 interfacing of LCD with I2C model. So if you previously I will show for LCD display, but many pins are connected to this Arduino microcontroller. But this type of I2C model, if you connect means this is the I2C purpose is integrated circuits. Here the 16 pin it will be converted for these 4 pins, the 5-volt ground and SDA and SEL. So here it is connected for the 4 pin is connected to the 5-volt is 5-volt and ground to ground, and SDA pin is connected to the 21, SEL is connected to the 22. So this type of way, if you connect for the LCD display, easily you get these. Previously, I will show in Proteus simulation software, the Hasan Medica, Rajabalayam and Sivagasi, the many pins I will connect it. It's like RS, enable, D4, D5, D6, D7. So these are the pins are connected previously, but this way you have to connect for this LCD display. If you move 4 pin is enough. The 5-volt ground and SDA and SDL. SDA means serial data and serial clock. Here the I2C address. Say if you are integrating of hardware, the I2C address is very important. Mainly 0x27, 0x3f. This type of LCD display only manufacturing for this LCD I2C. So if you are two integrating of both I2C values, if you place in your code, if you are upload the code in your ESP32 microcontroller, the LCD display, the functions it will be operating. So depending upon your code based, the LCD display it will be displayed. And if you are ESP32 integrating of LDR module, so this LDR is night time. If your LED light will be on, and morning time the LED will be off. That is the purpose we are integrating the LDR sensor, light depending resistor, and real-time hardware implementation of. If you are here, I will integrating of one SPO2 sensor, one Arduino board, and one LCD display. So this LCD display it will be monitoring for human heart rate and blood oxygen level. The future of IoT, the endpoint managements and automations and security integrations and active engagement and artificial intelligence, analyzing, sensing, scaling, connectivity. So these are the places we are used for this IoT. So this is a sample example of AC and bulb, TV and fridges and bus, otherwise your computers or locking systems, indoor locking systems and remoting systems and security cameras. So we are integrating the IoT applications. Thank you. So if any doubts means ask to me, I'll help you.
Thank you, Bodhi sir.
Thank you, sir.
Okay. Thank you, sir. It's a fantabulous presentations given. Participants, any queries? You can ask. Okay, participants,
Hello.
you can ask your queries.
Hello. Sir, namaskar, sir. Hello.
Yes, sir. Tell me, sir. Yes, sir. Tell me, sir.
Sir, whatever software you have used right now, where it is available and how can I download it?
Sir, this is cracked version software only, sir, Proteus. So you have to download this. If you given the mail ID, I will share that software. If you're procedure based, you have to install that software, sir. This is cracked software only.
It is a desktop based application software, na?
Yes, sir.
Desktop based application of software.
Yes, sir. Yes, sir. Yes, sir.
So I'm taking right now a mail address on my message. Please send it.
Okay, sir. Sure, sure. So contact to Vinod Kumar, sir. Sir, நீங்க contact பண்ணிக்கோங்க. Hello.
Okay, sir. Okay, sir.
Sure, sir. Any doubts, participants? You can make ask.
Sir, during the session itself, so many questions are there in the chat box. You may raise questions one by one and sir may answer.
Koti Rajan sir?
Yes, sir. Yes, sir.
There is a questions in chat box. When converting the data received from LMS 35 into Fahrenheit, you use following expressions.
1 minute, sir. 1 minute. I will check it.
Okay, right.
In the software name is Proteus 8. Proteus 8 version I have to use it. Many versions are available, 8.1, 8.2, that type of way it is available. Proteus simulator, right? No, this is not a open source software. This is for cracked software only. Okay, so if you download and if you install the license file only, it will be running. So this is cracked software only, not a free open source software. If you are hardware checking purpose, we are using this type of softwares. Okay, 600 watts. So I will share that software to college. You have to get it.
Sir, Koti sir, one question from my side.
Yes, sir. Tell me, sir.
How to store the real-time data get from the various sensors to database?
So many databases are available, sir, in free versions on Firebase and ThinkSpeak and AWS. The many databases are available, cloud storage based only. 1 GB is free. If you are going for above 1 GB means if you are getting a pay. If you get pay only, it is possible.
Okay, sir.
Okay. Emergency integrating.
More questions from participant side?
Namaskar, sir.
Yes, sir. Tell me, sir.
Sir, you have shown the devices that actually I think it's not manufacturing in India. So my question, I already put this question in earlier session also. So my question is that when our country will able to make these equipments within our country. So we will not able to depend on the other countries. So our students and researchers can use this software and this hardware, and it should be easily accessible for the users. is not as a part
Sir,
of
your
the.
voice is in a little bit only. I will get it, sir. Your voice is not audible. Hello,
Sir,
sir.
hello.
Yes.
Now,
Tell me, sir. Yes, sir. Yes, sir. Tell me, sir.
uh, my question is that now you have shown these devices that is not. I think that is not manufactured in India. So
Okay.
first of all, we have to manufacture those devices in India, and it should be circulated in a very low cost to the students and researchers, so that we all are able to use these softwares, use these software and integrate with these equipments, so that we can do something using these IoT technologies. So first of all, our first step should be the to manufacture these equipments in our country. We should not depends on other countries for these equipments. It is my suggestions. And what is your opinion? I want to know why when our country will be able will capable of doing these equipments, manufacture these equipments in our country.
Okay, sir, it is possible, but we are strongly in power electronics based only. We are creating the circuit. It is possible. It's like a PCB, printed circuit board. First one is. Next one
Yes.
is if you are find the resistors value and capacitors value. If you do the R&D, right? So if you are example, one IR sensor is there. That IR sensor inside one operation amplifier is there. The operation amplifier is 8-pin IC. You are giving the power supply 12 volt or 5 volt. If you given power supply means it is getting the two values. It is if you are plus and minus, it is getting on output value. So we are strongly in power electronic based means we are manufacture also it is possible. But why it is not going for manufacturing means that sensor is available in very low cost. That IR sensor cost is around 30 rupees, but we are making cost is around 300 rupees or 400 rupees it will be taken. Why means we are manufactured for only one devices, but that people it will be making thousand or 2000 pieces are it will be making. So that's why if you are manufacturing if you are manufacturing means it is very loss. So that's why we are taking this product and integrating the sensors, it is getting the output.
Hello. Hello. Hello.
Hello, sir.
Hello.
Yes,
Yes,
Pranav, sir.
Yes. So, okay. I think sir is disconnected somehow. Voice is not coming.
Oh, 1 minute, sir. Ojirasan, sir. Hello, sir.
I'm just discussing.
Sorry for the inconvenience, sir.
Antaran.
My laptop is switched off, so that's why
Okay.
you come for my mobile.
Okay, right, sir.
Okay.
Okay. Yes, tell me, sir.
Pranav, sir, we have any queries?
No, it's okay. Okay.
Okay, right.
Because now we are entering into a learning atmosphere, educational learning atmosphere, digital literacy skill to enrich our education system. My suggestion is that first of all we have to create an hardware equipments. Then we should go for the learning and chips.
Okay,
And
sir.
it should
But
be
if you
available for
are many of the people, if you are studying the yes power electronics based, he will study means he will create the sensor is very easy, sir.
Okay, sir. Okay, sir. Okay, Namaskar. Thank you.
Okay.
Your presentation was very nice and wonderfully. I watched this, and I'm very impressed with your presentation, sir.
Thank you, sir. Thank you.
It was excellent, sir.
Okay, sir. Thank you. Thank you.
I have learned lot of things from your softwares and your discussions.
Okay. Thank you, sir.
Thank you, sir. Thank you once again. Thank you very much, sir.
Thank you, sir.
Any queries? Okay, it's time for vote of thanks. Now I invite Dr. B. Vinod Kumar, sir, Assistant Professor, Department of Computer Application, to propose a
Thanks.
session.
Thank you, sir. First of all, I would like to thank our college management and our beloved principal, Dr. C. Ashok, sir, for giving the opportunity to conduct the ATAL FDP. Next, I thank our head of the department, Dr. R. Venkatesh Kumar, sir, for his continuous encouragement and guidance throughout the entire system. Thank you, sir. I would like to thank Professor R. Jagannathan, sir, academic advisor, and Dr. N. Sendil Kumar, sir, coordinator of IQC, for spending your valuable time with us. Thank you, sir. On behalf of Computer Application Department and on behalf, I extend my heartfelt thanks to our eminent speaker, Dr. N. Podirasan, Director, Hassan Medical, Rajabalayam. The topic, Advanced Medical Sensor Interfacing using IoT, for making excellent presentation and making this program interesting and meaningful, sir. Thank you so much, sir.
Thank you, sir.
I thank our organizing secretaries, our department faculties, and faculty of various colleges for their wonderful support. Once again, I thank you all. Thank you.
Thank you, Vinod, sir. We hope that today's sessions are highlight the FDP titles, which is helpful to everyone who attends. We are truly grateful for everyone participations. Tomorrow we meet about the upcoming sessions. I would like to thank everyone. Thank you. Feedback form is available in chat box, so all the participants are requested to fill up the form.